All right, boys and girls, in this video, we're going to look at one more way that you could model a whole number times a decimal. So we've got a lot of models for these. Here's just another way that they could show you a problem, and that is they could show it to you on a number line. And so the first thing that I would teach my students is when you look at this number line, you have to know what type of number line are you looking at. Well, it's easy to tell on this one because it's labeled for you. This is a tenths number line. But you have to be really careful with this, and you have to understand, well, why is it a tenths number line? Why is it broken up into tenths? And so I would definitely have that discussion with my students. And so I would hope you would know from fourth grade or lower, but if it's slipped your mind, then we need to have that discussion first. And that is, if I really wanted to break down this number line and I think about, what am I looking at here between whole numbers? So like between the 0 and the 1, I have 10 spaces. It is cut into tenths. And so, again, that's how you can, with any number line that you're ever dealing with, or ruler, because basically a number line is like a ruler, you can always stop and think, okay, well, what are they counting by? What is this broken up by? And it's however many parts you see. Well, there's 10 parts between the 0 and the 1. And so there's going to be 10 parts between the 1 and the 2, 10 parts between the 2 and the 3, and then so on. So this is cut into tenths. So everything I'm thinking about on this one is going to be about tenths. Okay, so I'm going to erase my stars here. So we need a problem. This is what you guys are going to be facing in class, and it involves your multiplication. So I'm going to take the problem 4, and I'm going to times it by 3/10. So it's a really basic problem, but you're going to have to be, it's kind of like this. You're expected to be able to model this problem, or if it's modeled for you, to analyze it and come up with, okay, well, what do they mean by that? And so if you have this problem 4 times 3/10, then you're going to first think about modeling it with, you think about it a couple different ways. One, if your whole number is 4, then that should be, basically the repetition. We're going to see something 4 times. And in this case, we're going to see 3/10 4 times. And so a lot of times what they look like on this is they're kind of like jumps. They're just like they jump from one little mark to the next on the number line. And so what I'm going to model here on this one is as good as I can on my iPad is I'm going to start at the 0, and I'm going to make one jump to the 4/10 mark. So that's one of my jumps, and it's kind of like this. Whoops, scratch that. I had a brain fart. It's always good to catch your brain farts, I guess. I'm going to actually make it to the 3/10 mark. My fault on that. So I'm going to stop at 3/10, and I'm going to think, okay, I just traveled from the 0 to the 3/10, so I've made one jump. Well, I want to make another jump, and so I want to carefully give myself time, kind of look ahead and think about where I'm going. Now I've made 2 jumps. I've gone 3/10 twice. All right, if I go another one, stop there, and then one more would be me modeling this problem, basically. And it seems kind of, like, oh, wait, you didn't do a whole lot of work there. Well, if I kind of take a step back and look at what I did, I can now put everything together. My jumps that I have are my whole numbers, in this case 4 times something. My 3/10, like every time I made a jump, it was 3/10. So there's 3/10 there, there's 3/10 there, there's 3/10 there, and there's 3/10 there. So there's my 3/10. And then wherever I landed, I'm going to put an arrow here. That's where I stopped. That should be my answer. Well, I stopped on the second mark. I'm going to put a big dot here. I stopped on the second mark past the 1. So my answer should be 1 and 2/10. And I could check that with an algorithm. I could go, okay, well, let's just go and see what this gives me if I solve it. Well, if I solve this problem, 4 times 3 is 12, but I'd have to make one move here with my decimal, and then now I could tell something must be right. All right, on this one, this model here is represented by a hundredths number line. Hundredths number lines are a little bit harder because you are looking at spaces that are much smaller and they're a lot closer together. So this one's not very common just because visually it's very hard to see, but it's still good practice and it's still good to maybe see what's taking place on a problem like this. And so we're going to practice one here. I'm going to come up with a problem. I'm going to put, let's see, I'm going to do 3 times 11 hundredths. Okay. So, same as the previous one, I'm going to think about making jumps here. And so I'm going to start at the 0. And here's kind of what you'd have to stop and think about on a hundredths grid. Like this hundredths grid now, or not grid, but hundredths number line, this number line now is stretched out from 0 to 1. That's all you're seeing. Like it's a really, basically it looks kind of big, but you're just going from 0 to 1. You see a lot of little marks in between, but you have to understand what those marks mean. Every time, and I'm going to draw an arrow here, every time you get to a bigger line on this hundredths number line, really you're counting up by 10. So you're getting to that line, that's 10, and then another 10 would be 20, and then 30. And so you'd count all the way up until you got to 100. And so if you got to 100 hundredths, that would be the same thing as the whole number 1. And so 3 times 11 hundredths would look something kind of like this. So I'm going to start at my 0, and I'm going to make a jump, and I'm going to land on my 11th mark. And then from there, I'm going to make another jump. And again, if you were really doing this, you would probably count like, okay, let me count my next 11, and then I kind of know where to stop. The one easy thing about doing these, if you're ever making them on your own, basically it's just skip counting. And so it's kind of like, all right, now if I go up another 11, I know 11 times 2 is 22, or 11 plus 11 is 22. So I need to know that I'm going to be on that 22nd mark. So it's going to be kind of somewhere in there. And then if I do one more, I'm going to be on that 33rd mark. So somewhere about right in there for my final mark. And that's because if I look at this model here, my problem is 3 times 11 hundredths. Well, I've got my 3 groups. I've got my 3 jumps, basically. That's what that means there. So that's where the 3 comes from. And then every jump was 11 hundredths. And then wherever I landed, I'm going to put a bigger dot here. Wherever I landed should be my answer. And I landed on the 33rd jump, or mark, I should say, and that ends up being 33 hundredths, which again, if I check it with an algorithm, it looks like a math fact to me. 11 times 3 is 33. You make 2 jumps. You make 2 jumps here. You get 33 hundredths. So these aren't too bad. These like to show up on tests, so you definitely are going to need to know how to do these or to analyze these. It's really important that you just go slow and look at these carefully.